Good and poor conductors of electricity. Good conductors of electricity are the materials which allow current to pass through them, whereas poor conductors of electricity are the ones which do not allow current to pass through them. Good conductors of electricity include most of the metals like copper, aluminium, iron, cobalt, nickel and many more. Anything made up of these materials is a good conductor of electricity. Steel utensil, safety pin, copper wire and steel almirah. Poor conductors of electricity include wood, plastic and rubber. The wooden bed, plastic handle of the utensils and rubber chappals are the examples of poor conductors of electricity. Let us perform an activity to check which materials are the good conductors of electricity and which materials are the bad conductors of electricity. Take a safety pin and a matchstick. Take 2 sets of electric cell and bulb. Take 6 pieces of wire. Connect one end of the cell with the bulb and the other end with the safety pin. Use the third wire to connect safety pin with the bulb. Do the setup for matchstick also. What do you observe? We observe that the bulb which was connected to the safety pin glows, but the bulb connected to the matchstick does not glow. Why is this so? It is because the safety pin is a conductor and allows the current to pass through it, and hence the bulb starts glowing, whereas the matchstick does not allow the current to pass through it, and hence the bulb attached to it could not glow. Connect free ends of the tester with each other only for a second or two, and if the bulb glows, the tester works perfectly. Remember, if it is done for a long time, the battery will vanish quickly. Liquid conductors. Let us find out whether liquids can conduct electricity or not with the help of activities. Make an electric circuit as given here. Dip the 2 free ends of the wire in the cap filled with vinegar. While doing so, remember that the free ends neither must be far apart nor touching each other. What do you observe? We observe that the bulb glows. How does it happen? The vinegar was present in between the free ends of the wire. As the current flows from the battery to the vinegar, it allows the current to pass through it. Hence, the circuit was completed and the bulb started glowing. Hence, we can say that the vinegar is a good conductor. Have you observed the brightness of the bulb? Is it as bright as it was in the case of the safety pin? No, it is dimmer than the safety pin. Why is it so? A bulb glows because as current flows through it, lots of heat is generated, which heats up the filament of the bulb, and hence it glows. The current through the vinegar might be very weak as compared to the metals. So, a weak current cannot generate ample amount of heat, and hence the bulb glows dimmer, and in some cases it does not glow at all. Our bulb tester fails to detect a weak current in the circuit. Diode or LED can be used to detect weak current. It has 2 ends or leads. One is longer and the other is shorter. The longer lead is attached to the positive terminal of the battery and the other with the negative terminal of the battery. We can even use a magnetic compass in our tester to detect weak current. You might wonder how it will do so. Well, do you remember that current has magnetic effect? If you keep a magnetic compass near a current-carrying wire, it will show deflection. We can use a magnetic compass simply in place of bulb in our tester. If there is any current in the circuit, however small it may be, the compass will show deflection. We can do similar tests with lemon juice, vegetable oil, milk, honey, tap water, salted water, and distilled water. And we find out that the lemon juice, the tap water, the salted water conduct, whereas the honey, the milk, the vegetable oil, and the distilled water do not conduct. Here we see that the distilled water cannot conduct, whereas the salted water and the tap water can conduct. The tap water contains impurities in the form of salts, whereas the distilled water is free of such impurity. So we can say that any salt added to the distilled water makes it a good conductor of current and electricity. Chemical effects of current. Let us perform activities to know chemical effects of current. Take two cells, two copper rods and long wires. Join the copper wire to the positive end and the other with the negative end of the battery. Dip these rods into a salt solution with metal caps above the water surface. In such a setup, these rods are called electrodes. Observe both the rods carefully. Does anything happen at the electrodes? Yes. When current passes through a conducting solution, some chemical reactions take place, such as the deposition of mass on the electrodes, evolution of gas bubble, and the color of solution fades. All these changes are termed as the chemical effects of current. For different solutions, different effects may be seen. We can see chemical effects of current on fruits and vegetables also. Let us do an activity to understand this. Take a potato. Cut it into two halves. Take a tester having magnetic compass. Insert free ends of the tester in the potato. Observe the setup after 1 hour. What do you observe? As we remove the free ends of the tester, we see that the end, which was connected to the positive terminal of the battery, has left a greenish-blue color spot. But there was no such mark anywhere else on the potato, not even beneath the other end, which was connected to the negative terminal of the battery. This confirms the chemical effects of current on vegetables.